Next up, we have interpreting the y-intercept of the regression line. So the idea here is, as I spoke about in the review of slope-intercept form, the y-intercept tells us the y value when x equals 0. But this is just for the line itself. It doesn't necessarily make sense in context. So it tells us the y value when x equals 0 for the line. A brief warning. It may not make sense in the context of the problem. So that doesn't mean the line is wrong. It's just we shouldn't interpret that part of the line. So depending on the context, it may not make sense to interpret. So when does it make sense to interpret the y-intercept? We have a few key things to keep in mind. So first up is we want to make sure that x equals 0 makes sense in the context of our explanatory zero, or our explanatory variable. So does x equal 0 make sense in the context of the explanatory variable? So for example, if x is referring to the length of a newborn, in inches, then x equals 0 makes no sense, because no newborn is 0 inches long. So that's the first question we should ask. I need to give myself lots more space. One moment. Okay. Next up, do we have data close to x equals 0? Or does it make sense to have data close to x equals 0? So the reason this question exists is if our scatter plot has all of our data out here, so we know that our line fitting the data looks something like this, we only know that the pattern exists where those points are. So we have no evidence that the pattern would continue going back to x equals 0. So there's no evidence that we could continue the line. So again, the equation for the line will draw a line that goes all that way. But if we don't have data close to that in statistics, we're just trying to observe a pattern. We only have observed the pattern where we have that information, where we have the data. We have not observed the pattern where I did the dashed line. Next up, does the y value make sense? In context. So we want to know if it makes sense for the y value to actually happen when x equals 0, or just in general. So for example, if the y variable is referring to, say, weight of a newborn, then a y-intercept of negative 1.5 would make no sense. Right? A newborn can't weigh negative 1.5 pounds or whatever it is. So for these, if we want to interpret, if any of these questions have no for an answer, then we should not interpret. So if any of these questions have no for an answer, then we should not interpret. So it does not make sense to interpret the y value, y-intercept. On the other hand, if all are yes, then we can go ahead and interpret. So basically, this is just a point in time to check yourself and to see, well, the line says I have a y-intercept of here, but should I talk about it in the context of the problem? So here, let's do a couple examples. So first up, a study was run on the relationship between height and weight of adults. A linear relationship was found with regression line y equals negative 370 plus 8.2x and correlation coefficient R equals 0.76. So a key thing here, we want a linear relationship. If we don't have a linear relationship, why are we fitting it with a line? So it's extremely important we need the linear relationship. And then we check our context. So in this problem, height will be our explanatory variable. So height is our X. Weight is our Y, or our response variable. In this problem, the number with the X is our slope. And the number without the X is our Y-intercept. If we run through our questions, question 1 was, does X equal 0 make sense? So X equals 0 would mean that the height is 0 inches. Which for an adult makes no sense. In fact, it makes no sense for any people, right? Adult or not. So in this case, this is a definite no, and we can go ahead and just say it does not make sense to interpret the y-intercept, or we could continue running through. But since we got our no, we can say it does not make sense to interpret the y-intercept. Again, this does not mean the problem is wrong. It just means that we should not talk about what the y-intercept means in this case in the context of the problem. All right, next up, a study was run on the relationship between the inches of rain the previous night and my commute to work in minutes. A linear correlation was found with regression line y equals 34 plus 31x and correlation coefficient r equals 0.51. So again, we do have a linear relationship, a linear correlation. The most likely explanatory variable is inches of rain the previous night. That's more likely to impact your commute time than your commute is to impact the rain. So this is my x, and my commute time to work is my y. So for this line, the 30 plus 31 is my slope. 34 is my y-intercept. So we run through the problem. First thing we need to ask, does x equals 0 make sense? So when x equals 0, that means that we are saying that there were 0 inches of rain the previous night. And this is certainly possible. Right? We have lots of nights in the area where there is no rain. So this is definitely possible. So this is our first yes. Next up, Do we have data at x equals 0, or are we likely to have data close to 0? Again, it is definitely likely that we have plenty of nights with 0 inches of rain or close to that in our study. So this is another yes. And then next up, does the y value make sense? So in this case, we had for the y-intercept, when x equals 0, we get that y was 34. I believe that is what my y-intercept was. So when x equals 0, y is 34. And we're talking about commute time to work in minutes. So this is saying that the commute is 34 minutes. And that could absolutely be reasonable. Not knowing my commute, obviously you wouldn't know, but it certainly is reasonable that someone could commute 34 minutes to work. So all of these work. So this means that we are clear to interpret. So the way that the interpretation works is we say essentially if x equals 0, or when x equals 0. So if blank, so this first blank is x equals 0 in context. So if there was no rain the previous night, then we would predict next up is the y variable. So we would predict my commute time to be, and then this is our y-intercept, 34 minutes. So a little key thing here that we would predict, again, the regression line isn't what actually happened. The regression line is just what best fits our pattern in the scatter plot. So it's not guaranteeing that this is what will happen. It's just this is sort of what the trend looks to show. Right? So this is how we go about interpreting the y-intercept. Again, it's very important that we run through and check that it makes sense to interpret before we go ahead and fill in our sentence. We all have a tendency to start kind of just following, getting in a rhythm and sort of reciting answers. And so it would be easy to write a sentence that seems ridiculous, but not even think about it, because we know it's if whatever x equals 0 means, we would predict the y variable to be whatever the y-intercept is. It would be very easy to recite something absolutely insane and not think twice about it. So before you go to write the sentence, make sure it makes sense to write the sentence. Right, that is interpreting the y-intercept.